In this example, we will plot the point 3 comma pi over 3 and the point 2 comma negative pi over 4, and we will give two additional representations for each point, one where r is greater than 0 and one where r is less than 0. For this purpose, we have a polar coordinate system here on the right side overlaid with additional axes for convenience. If I want to plot the first point, 3 comma pi over 3, there's a couple different ways that you can approach plotting points. You can either read r first, the directed distance, or you can read theta first, the measure of standard rotation. If, for example, you choose to read r first, the way you would think about that on our diagram here on the right side is 3 means walk 3 in the direction of the polar axis. So 1, 2, 3. So that would put us over here right now. Then rotate an amount of pi thirds in standard rotation, which means counterclockwise rotates an amount of pi thirds. Put us roughly up here. We think about the unit circle, so somewhere in quadrant 1. So our point then would be at the end of that rotation. So this point here is our point P. That's how to think about it if you do the distance first. If you instead do the angle measure, then what that means is rotate an amount of pi thirds. So face towards pi thirds. And then once you're facing towards pi thirds, walk a distance of 3 in that direction. 1, 2, 3 would put us at the point P. Just like with x and y coordinates, where you technically can read x first or y first, it's really up to you. With the second point Q, which is 2 comma negative pi over 4, again, you can go about that in either way you would prefer. If you do the distance first, you would walk 2 in the direction of the polar axis, and then rotate negative pi over 4, which would be counterclockwise, an amount of pi over 4. So that would put us here in the unit circle. That would be around quadrant 4. If you do the angle measure first, or the standard position rotation first, then this would mean rotate pi fourths or negative pi fourths first. And then when facing in that direction, walk a distance of 2, which again puts us at the same place. Whichever way you prefer graphing polar points is up to you. They both are sufficient. But that's not the end of this question. We also want to find two additional expressions for each point. One where r is greater than 0 and one where r is less than 0. Note that both these points already have r greater than 0, but we're finding another way to represent this same point that has probably the same radius. So, the way we're going to come up with another point is not just rewriting 3 in another way, like rewriting 3 as 6 divided by 2. That's still the same values. We want to get a different set of values. But if I want r to be greater than 0, what I'm going to do is I will keep r as it is and simply change our angle measure. Because if I want to still end up at the same point P up in the unit circle, quadrant 1, I could still end up there if I rotate a full amount. So if I rotate another full 2 pi. So if I rotate another 2 pi, I will still end up facing the same direction and then can walk an amount of 3 paces towards that direction. So another way to rotate this, or to represent this, would be, say, pi thirds plus 2 pi. That would work. This is not the only answer for that. You could also subtract 2 pi, or maybe add 4 pi if you want to rotate multiple times. But this is just one other representation that has r to be greater than 0. If you want a representation where r is less than 0, well, what we'll do with that is still keep the same distance from the pole. So I still want to keep the same absolute distance from the pole of 3. But if I want it to be less than 0 or negative, then let's go with negative 3. However, I can't just keep the same angle measure. I can't just keep pi over 3, because negative 3 in pi thirds would mean turn towards pi thirds and then walk backwards a distance of 3, which would push us in quadrant 3 of the unit circle. So not in the same place. But if we're walking backwards, then let's face the opposite direction. So currently we are rotating pi thirds. Let's turn around from there. So face the opposite direction by adding pi to this. If I face the opposite direction towards quadrant 3 and then walk backwards from the direction I'm facing, I will end up in quadrant 1 again. So I can come up with another representation by, say, adding pi. Or maybe you wanted to subtract pi. That would also work. That would also represent p. Maybe you want to add 3 pi. That would also work, as you'd be adding pi and then finding another coterminal angle measure. There are many ways to represent this, but because the question doesn't restrict what theta needs to be or the angle measure needs to be, then we can go with anything. If we do the same thing to point Q, which is 2 comma negative pi over 4, apply the exact same concepts. It doesn't exactly matter what the values are. For Q here, if I want r to be greater than 0, I will keep r to be positive. And I will simply find a coterminal angle measure for the one that I'm provided. So instead of negative pi over 4, we could add 2 pi or add any number of 2 pi or subtract. So maybe I want to represent this by subtracting 2 pi, which would overall give me negative 9 pi over 4. That would still be okay. Really up to you. Or if I want r to be less than 0, let's make r negative 2 this time. If I have a directed distance of negative 2, so I'm walking backwards, then I want to face in the opposite direction of where I'm currently facing. Meaning I can take pi fourths and add pi like I did in the previous case for p, or you could also subtract pi. Both are equivalent ways of finding another representation for this point. So I just showed a couple ways to do this. If you want to, say, add 2 pi and add pi respectively, that's fine. If you want to add or subtract other coterminal angle measures to get to the same kind of angles, that's fine. Technically, there are an infinite number of ways to represent these points.